Hello everyone. Today we'll have a guest session by Murli. Murli is currently a master's student at UCSD, University of California, San Diego. And he'll be giving a guest session on SEO meets NLP. He'll present a new topic that you can learn, go and build a product out of it. And it's at the cutting edge of what NLP can do at this time in the SEO space, search engine optimization space. There are only companies, a handful of companies that are coming out in the exact topic in the last less than 6 months ago. So the industry is ripe for disruption if you want to go ahead with it as well. Without much delay, let's get started with Murli's talk.
Hi everyone. Thanks Ramshi for the introduction. Hi guys. It's quite a bit early here in the US, so sorry if it is visible on my face. So I'm very excited to have this discussion with you guys. I'm also kind of like a student like you, but have some years of experience maybe in similar domains. So the goal of the today's presentation is I'll briefly introduce myself and then demonstrate a few working examples of how NLP and AI can be used to solve some real world problems and products. I'm not sure if all of the backend technologies are covered because it kind of is an introductory course, but some of them maybe are familiar to you, some of them are maybe not. But the overall goal is to showcase what we can actually achieve with NLP and AI. So yeah, about myself, I have kind of an untraditional journey, like a few guys. I'm a mechanical engineer, then started with analytics and then data science, and then currently focusing on ML and NLP. I have like 5 years of work experience in this space, mostly with a company called Trident Analytics in India. We mostly worked on data science consulting for Fortune 500 companies. And currently, I'm pursuing my master's, machine learning data science master's at UCSD. I'll ask Ramsi to share the LinkedIn link with you guys. We can connect if you want to have any further discussion about any of this. Cool. Jumping right into the topic. Now, so one of the kind of product which is kind of an early stage that Ramsi and I are trying to build is auto SEO. So for guys who don't know about SEO, it's basically once you write some particular form of blog or a content, and it is available on online internet. So Google basically tries to rank your content and showcases based on keywords that a user hits. Let's say if you type in, let's say, machine learning, the top 10 blogs that come on, or top 10 articles or blogs or web links that come on the Google search page have certain functionalities that made top 10, and a lot of marketing people try to beat that algorithm to make their position in the top 10. And it depends on a lot of stuff. Google obviously doesn't release their exact algorithm, but it releases what all parameters or what all features it depends on. So the whole idea of SEO is that we optimize our content as much as possible to make it to the top 10, so that organically people can click onto our content and come to our product or service or whatever. Now, the major challenges are, let's say you have some business and you want to identify what are the best keywords that are currently trending in the market. Let's say your business is about, let's say you're providing services on Photoshop services, but in Photoshop business, there can be a lot of tools like regarding the products, regarding what kind of output that you want to get, or etc. There can be a lot of keywords related to your business, and identifying what keywords should I write on, what are the top trending keywords is one major area for SEO marketers. And next is search intent. So this is so basically if you type machine learning, user has certain intent in mind. Let's say, is it to learn machine learning? Is it to have some tutorial in machine learning, or is it to implement some machine learning algorithm? Or is it to learn what are the different types of machine learning that are there? So people usually not type like complete English sentences, but their intent is somewhere hidden in that 1-2 keywords that they usually type. So understanding that search intent is really important to associate one particular keyword with, hey, what my user is exactly wants. Next is readability impact. You may have seen tools like Grammarly, etc., where they're providing to make it more grammatically correct, and also trying to provide some tools to make it more syntactically correct. Also, in the business of SEO, along with keywords, it is also important to make the audience click your website. So basically, the effectiveness of your writing also matters, not just your knowledge about that particular topic. And finally, there is a lot of other meta content, which also Google uses to rank these articles, which are like images, meta description, product tags, etc., which are also related to your HTML part of the website, but we're not going into that area right now. But overall, I hope you got an idea of what is SEO business, and what are the key challenges, and what are some existing tools that we have, and how NLP, let's see how NLP can actually try and solve some of these problems to put in together. Now, today, I'm going to discuss about three major topics. One is key topic extraction. I was actually joined just to see one of the methods that Ramsri was discussing. So I'll also maybe bring in some other view and showcase how I'm using it differently to identify key topics. The second is understanding user search intent. This is basically trying to use some scraping tools, some kind of summarizer, and some existing tools to identify the exact intent of a user search when they search a particular keyword. And the third is how to modify the headlines to make it more impactful. All of these are in kind of a nascent phase. We can have a discussion, but these are not like, hey, this is the exact way to go about it. Definitely, there are multiple ways, but these are definitely very good starting points for this to solve these problems. If you don't have any questions, I'll just directly skip through one by. So for each of them, I have 2-3 slides, and so maybe it will take like half an hour more just to discuss all three topics. Okay. Now going ahead, yeah.
Sounds good. Yeah, we'll have questionnaire at the very end to answer all the questions.
Sure.
Go with the flow, and we can answer the questions. Yeah.
Sure. Now the first one is the key topic extraction. So why is it important? Obviously, when you write a blog, Google identifies keywords, identifies key phrases, and it tries to rank them. So putting in the best keywords is at the utmost importance of search engine optimization. So let's try to see how this key topic extraction evolved in the last 5-10 years, and where we are at right now, and what method I have been using to generate some keywords, not generate keywords, but to extract keywords from the blogs that we already have. So there are traditional techniques. There are a lot of statistical methods like LDA, topic modeling, or rake that he mentioned. They all depend on some underlying probabilistic models and also certain assumptions on documents and words. So I'm not going to explain like every algorithm, but high level, what they have is each like a certain topic is a distribution of certain words, and certain document is a distribution of certain topics. It initializes with some random numbers in the probabilities, and then iteratively iterates through that process to identify, to try to cluster different words into different topics, etc. Now, the kind of pros and cons using these approaches, actually LDA was prominently used. I think it's still used till now to identify the best topics in generally when you have a set of documents. But the problem is there are three cons that I mentioned here. Is one of the thing is you have a lot of manual interpretation of the topic. It just provides you unigram keywords of machine learning, data, etc. You need to make sure that as a domain expert, you understand, hey, what this belongs to. And also there is a thing on unigrams. So basically, there is no special treatment for bigrams or trigrams. Obviously, when you say topics, they are a combination of phrases, and it can be sometimes a unigram or it can be sometimes a trigram. So you have to treat them like you have to do a lot of pre-processing on your own Let's say, for example, I want the phrase machine learning to be considered as single word. You have to replace all the machine learning with machine_learning so that your algorithm takes in as one single word. And also, if you want to generate bigrams and diagrams, you have to do the same way. Now, if you do it for all the words possible, that's also a problem. But identifying the words in the first place itself is also another problem. So it is a bit of an effort to extract unigrams or bigrams or more in this particular case. And also, it has an assumption that it depends. These algorithms depend a lot on frequencies. So let's say, for example, it is talking about, let's say, Tesla, but Tesla is not mentioned, and it is just mentioning the company or the car or something like that, which is kind of mentioning it a lot, but it is not actually mentioning with Tesla. These algorithms, which depend on probabilities of the word Tesla, won't really rank the word Tesla higher. So definitely there need to be some resolution of pronouns and a lot of other stuff to make sure that your Tesla is given the equal importance. So I think enough of the cons. So there is another algorithm. So the LDA topic modeling is mostly depend on the statistical probabilistic district model. Now, there are other algorithms. Researchers want to combine statistical and graphical models. And this paper is actually published in 2015, and we have also used it before. And SGRank is one of the other algorithms, which is also very simple. And you can actually read the paper with your current knowledge, and you can easily understand this paper right now. And it involves a lot of heuristics. So it extracts all the n-grams, and then it filters some of the n-grams based on where the stop word is, etc. And then it uses the standard algorithm of PageRank. PageRank, you might have heard that Google started with an algorithm called PageRank to rank their content. So it basically depends on the co-occurrence of two particular words. Let's say machine learning and artificial intelligence are kind of coming within a set of 10, 15 words together. It kind of have a very high edge weight of these two particular words. So it kind of works on statistical and graphical model. And there are very similar problems associated with the SGRank. A heavy dependence on frequencies, a lot of heuristics to adapted to domains, and need special treatment for n-grams. All of these are common. And there are many similar others like we just discussed. And now how deep learning models or any model that converts a particular text form into a particular vector has changed this paradigm is one way is to use sentence embeddings, let's say sentence transformers. I'll explain this a little bit more detail in the next slide. So the idea here is we use sentence embeddings to convert a particular text input to one single numerical vector. And then how we use it in the later process, we can do k-means clustering like he mentioned, or we can use some cosine similarity measures to just identify what two phrases are close, how close they're, what phrases are closest to the document embedding, etc. So there are a lot of design choices you can make, but the whole idea is to have some sentence embeddings for phrases and documents. And there are many more that are coming. You can check them out, but let's jump into how a keyword works in brief. So let's say this is your document. This is an actual document text that I picked from Google. It has some title saying, what are the top 5 Photoshop tools that you need to be like aware of or something. Now, the first step is you get the sentence embedding for the entire document. So this entire document have a particular direction in an embedding space. It is mainly talking about a particular topic called how a web designer should be aware of Photoshop tools in the Photoshop software. Let's say this is like a summarized version of this entire document. The sentence embedding tries to replicate that in some latent hidden space that we don't know of, but it has some numerical representation. Now, the next part is I take all the n-grams that are of interest to me. It can be all the possible bigrams, all the possible trigrams, or some way to identify some initial set of words that I have an interest on, and then generate embeddings for those phrases as well. Now, this is a very big design choice in terms of accuracy versus latency on how much search I need to do. That I'll try to cover in the next step. Actually, show some a couple of examples. But let's say you know that these are some 500 different phrases in this particular document that I'm interested in to see whether they actually are representative of this particular document. Now I generate all these phrase embeddings, and now it is just about identifying any similarity measure to check which of my phrase embeddings are closest to my document embeddings. So, and then take the top 5, top 10, top 15 based on your use case, etc. But the whole idea is taking a document embedding and then taking all the phrase embeddings and then checking which phrase embedding is like in a very similar, let's say cosine similarity or Jaccard similarity or like any similarity measure that represents two numerical vectors is how closest it is to my document embedding. So this is the very whole idea. So what are the advantages? We are using some pre-trained models to identify closeness. It is agnostic to n-grams heuristics. So all the problems are kind of solved. We have solved unigram bigram problem. It automatically identifies which one is best. We are not putting any heuristics at this point. Of course, let's say if your domain is biomedical, you need to choose a language model that is trained on biomedical. But that is a problem which has to be solved before. But once you assuming you are working on a domain independent data set, this problem is heavily solved. And then it also doesn't depend on frequencies. For example, it takes, so let's say there is a word called web designer, and someplace else there is a phrase called web developer. Both are by the definition of embedding, both will have a very close match with in general. So you don't need to worry about, hey, web designer versus web developer. Will I miss one of them because they share some frequency, etc. So this is like one of the tool to at this point to extract key topics. Very minimalistic setup. You just need to use embeddings for documents and phrases. Now, obviously, when you try to run this and put this on different blogs, you may see different errors, and we're trying to solve with different design choices. For example, this is the title of the blog, 5 best Photoshop tools and photo editing software for web designers. You can assume like what content it might have. And the other blog is the 6 biggest money secrets most rich people won't tell you. So you can see that Keybird is doing not a decent job because it has used Photoshop to remove, Photoshop for and help of Photoshop. You can start identifying problems and try to resolve one by one. So one of the problem is there will be a lot of phrases which are very close to the actual document. And these are the top 15. So the two problems I identify is there is a lot of noise in terms of stop words because let's say, for example, let's say use Photoshop and use Photoshop for. So these two are exactly same. But the problem is in general in deep learning, when you're working in the space of deep learning, you generally don't remove stop words because that kind of eliminates the semantic aspect of it. So what you try to do is once you get the results, you try to do some post-processing on if my stop words are in the first and last parts, they are kind of redundant, so eliminate. So these kind of heuristics you can put to eliminate them, but never kind of eliminate them in the first place. So also one more thing is there's no diversity. I know that Photoshop is one of the top phrase definitely for this, but after Photoshop, what is it? After that, what is it? There may be 110 phrases for Photoshop, 10 phrases for something else, etc. But we need to try to cluster this Photoshop and just return one output from this entire group of 10, right? So that's where intelligently identifying, hey, what are the n-grams that I want to look out for, and should I get in some diversity? So there can be two methods to generate the initial set of candidates, which is one of the method is spacey noun chunks. So in spacey noun chunks, if you have used spacey provides a very rich linguistic capabilities. Let's say you pass in this particular English sentence, it kind of tags noun, adjective, noun, etc. And noun chunk is basically something which has some 3-4 patterns in spacey, like noun, noun, adjective, and adjective, noun, noun, something like that. These are just linguistic abilities. Of course, because it is tagging each token by token, it is a very costly process in terms of speed. We are not talking about how are we solving for inference right now, but definitely spacey generates better candidate search space for our initial phrase embeddings. Now, once we have the results, so this is pre-embedding part, and post-embedding part, how can we select diversity? For example, the cosine similarity of use Photoshop is 0.99, and photo with Photoshop with the actual document is 0.98. And the next, let's say the magnetic lasso tool is 0.82 or something. So I will kind of eliminate the ones which are very close to one another, and then go to the next set of tools, so that you can see that with just 2 steps that we already know how to generate noun checks and select some diversity based on any heuristic method, we came up with a bunch of diverse and I think very useful key phrases. So let's say Photoshop, definitely yes, we want that. And then magnetic lasso tool, website designs. Definitely there will be noise, selected portion, surrounding colors. I think surrounding colors is really important in this particular scenario. The paint bucket tool, gradient, photo editing software. Definitely just by reading this top 10, 15, you will definitely understand what this particular blog is talking about. And in the next blog, you can see that it is mostly talking about becoming a millionaire, which is obvious. But here you can see about how I exactly can become a millionaire. I think they're talking about some free aspiration account, and then putting your funds in diversify fund, and then talking something about an online marketplace, some secret banking account, some high stakes tournaments. So you definitely are diverse in your key phrases, and they actually all make sense to what this entire blog is talking about. So yeah, so the idea was we used existing pre-trained model, and we put in our own approach of how can we use document embeddings and phrase embeddings in a certain smart way. There are a lot of design choices and we made to get to our top 10. These are not cleaned at all. These are directly whatever I got from the code, I put it here. These are not some selected list of phrases. So you can see the actual, the effort that I put in and the actual results that I got. Of course, so for your blogs, you may encounter some other problems and you can try to come up with your own algorithm. But one small advice is don't just use one blog to make your algorithm optimize for that blog. Use a set of like when you're doing an unsupervised techniques like this, this is an unsupervised method. Obviously, we're not training anything. Unsupervised technique like this, you need to have some diverse set of examples to try to make a generalized approach, obviously. Because, for example, if I see this particular set of examples, and then I see that, hey, I have a lot of a and in the starting, maybe I'll put a heuristic on removing all the das in the start, etc. But it may not really work well for the other blocks. So basically, if you're putting in some heuristics which are very heavily dependent on one example, just make sure that they are kind of generalized. So yeah, I try to put in as layman as possible. If you have any questions, I'll take them in the end, as Ramsey mentioned. Now, going to the next topic. Now, user search intent identification. So just to recap on the problem again, I'm just checking on the time. Okay. Yeah. Just to recap on the problem again. Once you put in a keyword, the whole idea of this exercise is, hey, what are you exactly looking for? That's it. That's the whole idea. Now, how will I solve it? So let's take this particular magnetic lasso tool in this particular blog to understand when people come in to search magnetic lasso tool, what are they actually looking for? And then in the second blog, let's try to see some high stakes tournaments. Let's say some people type in high stake tournaments. What exactly are they? What exactly do they mean? Now, we obviously can't ask the user, hey, what do you mean by it? We use the top 10 results of Google to understand what they actually mean. So the first simple step, not a simple step, I mean, it has its own complications. The first step is to get the Google search results. There are APIs, there are tools which are not authorized by Google. There are tools which are, Google used to provide some search APIs. I think now they're not providing. We are not going into the business of how do we get the top 10 results. But let's say you did the web scraping and you got the top 10 results. Now, what can you do? Let's say, for example, you can see that there are these top 5 results or something. And the content that is provided in this, because Google is putting them in top 10, that means they actually match what the user is looking for. So that's the whole assumption that we go with. And then we try to understand what this actual content tells us. Now, here, first thing is, let's say 10 blogs. Each blog is 800 word length on average. And then we get to 8,000 words. Obviously, good to do anything further, we need to kind of, and there will be, because let's say this particular blog is about simplephotoshop.com, they may have some advertisements in the starting para, ending para. So it all makes sense to summarize the entire blog content before doing any further refinement. And then I used GPT-3's TLDR summarizer. If you don't know about GPT-3, it is also like a BERT model, like we discussed before. It is pre-trained, and it will basically, with the advent of this, there is a lot of prompt engineering that happens. So just to give a quick overview, usually what happens is these deep learning models are used for fine tuning in general. Let's say you have a classification task, but you have just 10 to 15 examples. You fine tune your weights of the language model to accommodate your input as well. So that's when some of your domain or what exactly your examples are telling, the language model can adjust the weights accordingly. Now, once GTP3 started, instead of using that also, like even though there is no need of doing fine tuning as well, you can directly provide some examples in your prompt so that the prompt is a very good starting point for the model to generate better results. So it's as simple as you provide the entire content, and then you say that, hey, GTP3, I want a summarized version of this. And you just ask the GPT-3 model to produce a summary of it. It generates a summary because it understands the prompt and it understands the input directly in the prompt itself. Now, what category does it belong to? When you're doing any decoding of text generation, let's say if I input magnetic lasso tool and then ask next 10 words to the GPT-3, it has multiple ways to generate. And the two major aspects is whether you want to be very highly creative or you want to be very highly semantically precise in terms of the content. So summarizer falls in the bucket of where we don't want to be very highly creative, but we want to be capturing a lot of semantic meaning of the original text. Now, when you're doing summarizer, one definite trick is most of these language models are fixed by like 2048 token size or 1024 token size. So usually go with the chunking and striding approach. That means you've given the first 1,000 words, and then you can give in the next 1,000 words with some overlap because you don't want to abruptly cut some tokens, etc. But basically you try to, let's say for GTP3, you have 8,000 words, give first 1,000, next give 8,000 to 800 to 1,800, next give 1,600 to so on. So you pass in this as an input and then get all the summarizers and then just collate them simply. So the whole idea is we extracted the content from Google, the top 10 links, and then using some design and the GPT-3's some predefined prompt, which is the main objective is to have low diversity and high coherence. We generated the paraphrased version. And then now I used a tool like question generation. So now we have a paraphrased version of this entire content. Now we do the reverse engineering of, hey, if the sentence is present, that means what question is it exactly answering? So if we generate the questions using question.ai, I used the direct website to generate a sample of questions. I haven't integrated anything, but this still worked well. So this implies that the user's intent in the final answers is actually what they coming and looking for. Okay. So let's see some examples on, is this really working or how this fare? So this question is, I used magnetic lasso tool as my keyword and got a couple of Google search results to pass through this entire pipeline, the summarizer, and then the question. And then you can see that what keys are used to do something, what option changes are in the options bar. So basically, this is a very highly technical tool, as we can understand. And the top 10 results are actually talking about what is the selection tool to do of 90% accuracy, what is not adjustable when you started dragging, what is the most important powerful tools. So you can definitely see that, and as an SEO or a blog writer or a content writer, you definitely have a very good guidance on, okay, these are the questions that I should definitely cover in my blog so that my blog will also be matching with the search intent for this particular keyword and it can rank definitely high. And a very similar thing that I did for high stakes tournaments. When they say high stake tournaments, you also have no clue on what exactly Google will return, right? Because this is a very, what do you call, kind of like, it may have different meanings. High stakes tournament for us maybe have, is it a tournament of, let's say, horse riding, or is it tournaments of cricket or something? Or we don't know. But Google actually provides everything about poker. So we have to match that intent. So you can see the questions because, for example, where do we recommend to play? People want to understand where they can play high stake poker tournaments, which poker site has so and so functionalities, who has the few daily stake tournaments, which poker has the least number of players. So basically you definitely know that you need to cover something about poker if you want to target this particular keyword, and definitely you should cover the questions related to these in your particular blog to rank your blog higher in this particular keyword. So we kind of, just to summarize, we reverse engineered what this user intent is using the top 10 results of Google, using some version of summarization, and using some existing tool like Question. Of course, Question has an API. I mean, there can be other ways to generate questions, but even if you just get the paraphrased, even if you stop at this particular point and just read the paraphrased version, like the top 10 sentences, you can still understand what this intent is about, right? So this is a definite important tool to understand search intent identification. I'll just take 5 minutes more. Okay, we're coming to it. So now impactful headliners. I'm actually thinking of how can I use existing tools to make better headlines. Now, so the idea here is, let's say this headline is there, 5 best Photoshop tools and photo editing software for web designers. Most of the content writers inherently optimize for keywords. Like that is like our general intuitiveness on, hey, I should have Photoshop tools in my title. I should have web designers in my title, which is fairly decent enough. But there is a balance between the effectiveness versus the keyword placement. So I'm still trying to explore on what is the best way to make it more impactful, but still have those keywords in place. So most of the blogs that you see may have like the 6 biggest secrets most rich people won't tell you, but it is not drawing audience like immediately. So in a traditional, in a traditional setting, how will you do it? You try to replace with better ones we just talked about, but content writers usually take care of them. The ML way is you collect the training data of original headline and some impactful headline, and then try to build some model. It can be traditional logistic, I mean, not logistic regression, but any of the text to text kind of a model where you can try to map some input to the output. But the problem is with data collectors. Obviously, in this creative business, it's very hard to easily find data. And the deep learning way is kind of similar to above, but you need to fine tune it on existing language models. Let's say there are sentence to sentence similarity models where you can try to maximize that particular example. And then also with GPT-3, we have this beauty of prompt engineering where you can just collect a very few examples on what exactly is there in your particular mind. And then based on that innovativeness in the collection and the prompts, you can definitely see the magic of these language models like GPT-3. So what I tried was, actually, this is one of the blogs that Ramsri shared on LinkedIn before on 17 great tips for copywriting. So I converted this exact thing into my prompt. On the left side is Trello lets you work more collaboratively and get more done. And the right side is work collaboratively, get more done. So you can see that the first prompt example is exactly what this slide is talking about. Now, because this is a very highly creative application, unlike Summarizer, we want to be very highly diverse in the decoding strategies. So I used almost 100% and 100% temperature and topic. Don't worry about if these are not familiar to you. It's okay. But just understand that when you're trying to do some text generation, there are 2 sides to it: how creative you want and how cohesive you want. But this is on the way complete creative side. So you can provide all the examples like this, and then your input can be your actual input. Learn the 6 biggest money secrets from rich people. And then you just ask the GPT-3 to provide the next 10 tokens, and it generates something really beautiful. And let's see like how exactly it generated. So for example, I'll take the 6 biggest money secrets which rich people won't tell you. It actually generated invested, protected, spended, diversified income, expand your knowledge, or 6 money secrets that you can retire twice as fast as the cost. You'll learn a shortcut to the fortune. Learn how rich people think about money. Money doesn't make you rich, but the right money strategies do. These are really effective. Now you can argue, hey, this doesn't provide some keywords that are missing. Definitely, we need to balance it. I'm still working on it. But definitely, this is a good starting point on how, with a very few prompts like this, we are able to generate some unique headliners for our business. And obviously, these ones we don't need to use directly in the headline. There can be a lot of graphics, creatives, posters that I want to advertise my stuff on, and these definitely are worth a shot in your graphics and designs. And for Photoshop, you can see that to work faster and smarter, so it added certain adjectives. It is adding web design is incomplete without good graphics. So it went very creative. But it makes sure the meaning of the entire blog title is not going away. So yeah, so these are some of the impactful headliners using just some prompts that I found on some PDF of some website. So I think, yeah, so these are 3 major topics I wanted to cover. Yeah, so these 3 things I wanted to highlight. I wanted to emphasize the fact that NLP has came a long way from the traditional techniques to here.